Okay.
Okay.
Wait.
Hello, everyone. Welcome to the second and last keynote speech of the symposium. This is the second day of the symposium, and we've been listening. Welcome to the second and last keynote speech of the symposium. Okay, and sorry. Firstly, we have been listening to some great speakers for the past 2 days and with very interesting topics, and hopefully you're enjoying it as well. Firstly, I'm going to introduce you to our keynote speaker, Kirsten Haggart. She has 20 years of design experience working across sectors, and her strength lies in designing site-sensitive developments through the management of stakeholders and engagement with collaborators, successfully navigating public consultation and statutory authorities to pilot proposals through the planning process. Throughout her career, Kirsten has developed projects and concepts that push boundaries and change mindsets. From the pioneering Murray Grow, which altered the global perception of how CLT should be used, to Multiply, a carbon-neutral timber pavilion for the V&A Museum, which demonstrates how engineering timber structures can contribute to the circular economy. Her work challenges the status quo. Most recently, Kirsten has developed a visionary concept of Trenesia, a zero-carbon community of 1,600 homes and a cultural hub built over the lake in Bergen. Kirsten Haggart is a senior associate at Waugh Thistleton Architects. Waugh Thistleton Architects is one of the pioneer practices actively acting in climate action. It's a Shoreditch-based architectural practice producing thoughtful and sustainable projects in its own neighborhood and beyond. The practice is a world leader in engineered timber and pioneer in the field of tall timber buildings. So I'm very excited to hear from Kirsten. We also have here Selçuk Avcı, co-founder of The Circle and founder of Avcı Architects. And myself, I'm an architect and also the co-founder of The Circle. I think I can easily say we all share the environmental design passion here and interest in the sustainability and ready to act in the climate action as much as we can. The way we're going to do this keynote speech is normally if we were in a lecture hall, of course, we would sit down and listen to the whole lecture. But here it becomes a bit, because we can't see you guys, the audience, we want to create this interactive environment where Kirsten is going to do her presentation and you can ask questions anytime you would like on the chat box, like during, in between. If any question pops up, we're going to immediately, in an okay time, interrupt Kirsten and maybe give her the question. And so we can discuss what you're wondering immediately at that minute. And or also all of your other questions you can ask at the end. And also we have a half an hour networking session at Hopin, which you can face-to-face ask your questions. So I'm gonna first let Selçuk say hi and then let him give the floor to Kirsten.
I've been looking forward to this for a long time, Kirsten, because we've been talking about Waugh Thistleton's work, I don't know, for many, many years now. So especially Ece and I have been following you guys. We're very much into the movement and have our own roles in that in Turkey. But clearly in England, you've managed to put in some considerable mileage in that direction, having seen your work. It's incredible and looks very accomplished, and we're looking forward to hearing about it. So let's give the stage to you and listen.
Thank you very much. That's a lovely introduction from everybody, and it's so great to be here today. I'm just going to share my screen with everyone. I'm from Waugh, Thistleton Architects. I've been working here since 2004. Had a small break in the middle when I had my children. And we are a practice based in Shoreditch. This is outside our office when we went on the climate march before lockdown happened. But we're passionate believers in sustainability and how architects can help to save the planet. So our ethos is an integrated one. We are very much, we work very much as part of a team and are keen to involve engineers and service consultants, M&E consultants, as well, obviously, as the client and end users as much as possible. We approach each project in an innovative way, and we have quite an extensive range of research projects now within the office, which we try to bring into practice as much as possible. And fundamentally, we're building for the people that are going to be using the buildings. So placemaking and creating a healthy environment for people to live in is really key to what we do. We're across sectors, so we've worked with residential, commercial and religious projects, being shortlisted for the Sterling Prize with the Bushy Cemetery, which you see here on the right. And it's about using the appropriate materials for appropriate conditions. We're founding members of the UK branch of Architects Declare, which is an important part of what we do, and Andrew Waugh is one of the key contributors to that movement. So what's our idea? So we're the key purpose of our work and one of the founding principles of it is about building more in timber, because obviously trees absorb CO2, they store it in their tree trunks. And when you cut them down to make them into buildings and then replace the trees in a sustainable way with sustainable forests, as we tend to have in Europe, that carbon that is stored in the tree is saved in the building for much longer rather than it decomposing or being burnt. So the ultimate goal is if we build more with timber, then we can reforest the planet. And another key part of what this has led us towards is DFMA, so Design for Manufacture and Assembly. And what the link here is that CLT or timber manufacture tends to be a digital process in that you send a digital model from your building model and it gets cut in the factory. So this started a chain of thought within us, which you will see later in the way that we've developed various projects. But what that means is that you get a much more efficiency in the way that we build, and it's all about minimizing waste as we go forward, as we've heard from COP in the last few weeks. So we're running out of time. Again, we've heard this quite a lot recently, and concrete and steel are actually some of the biggest polluters on the planet. If concrete was a country in its own right, it would be the third biggest polluter. So we need to think about the CO2 emissions and where we can. Obviously, concrete is a very important material for a lot of reasons within buildings, and we're not ever going to get away from that. But it's where we can substitute other more sustainable materials to achieve the same goals. So, over the last 20 years, we've been thinking a lot, and I'm sure certainly in Sweden, they were pioneers, and I'm not sure in Turkey, but I'm sure there's huge moves there as well to reduce the energy that we use in our buildings. And we're getting better at doing that by substituting, we can use energy which is from sustainable or renewable sources such as solar panels. But what we haven't been so good at is thinking about the energy used to make our buildings. And we don't have a lot of time left. So we need to think about how we can substitute out those high energy using materials for more renewable, sustainable ones. And we can see through various policies and directives that are coming through in the UK that embodied carbon is going to be part of regulatory requirements going forward in the future, whether that's through planning policy or building regulations. And we're going to need to be able to calculate a life cycle analysis for every building that we submit. Certainly in London, the larger scale projects are already asking for this. And at the moment, it's a thing of they're benchmarking what the carbon footprint of buildings are currently in order to then set targets for how they should be going forward. So when we're thinking about this, as I mentioned, you know, the energy in use, so the lighting and electricity that we use in our buildings is often offset by renewable energy in the supply. With embodied carbon, what we can think about is the amount of energy it takes to use the building, but we can also think about how that can be offset against the carbon that, as I mentioned earlier, is stored in the materials that we're using. And then we've all heard about carbon offsetting as well, is another way of doing this. And this is a really interesting tool that you can actually use. It's done by Van Kunsten in Denmark, and it gives you the carbon content of different materials. So these are the high energy using materials. These are the low ones. And actually, if you use very little of this, then it's fine. But you want to be using more of these lower ones for the big structural parts of the building. And this gives you a sense of, you know, where we should be focusing our efforts. Obviously, in structure, which takes up the biggest part of a project, that's where we need to be thinking about what we can substitute in those areas. Obviously, retrofit is an important factor in how we're going to move forward with sustainability. So the more we can reuse existing buildings, the better off we'll be. And this gives you a sense of, you know, if you use a typical RC frame compared to a timber frame, when you account for the sequestered carbon, so the carbon stored in the material, then we're getting down to very low levels in terms of our carbon footprint. And there's lots of ways we can do that. And this is really the next part of the talk, is really to demonstrate how we've gone about this over the last 15 or so years. So there's cross-laminated timber, which is a panelized system. We've got glulam, often used with a CLT floor plate. And we've got laminated veneered lumber, which is a stronger version, if you like, of glulam. And this is one of the first projects that I worked on, which was back in 2008. And this was a honeycomb CLT structure. So those panels that I just showed you were just stacked on top of each other. We try and make sure that all the structural lines go all the way through the building, which is it was relatively simple to do in this project, which was a housing project. The whole building was, the structure for it was built in 8 weeks. So 8 floors in 8 weeks. In this case, so this is how it looked on the inside. It's a very healthy environment to work in. I think the electricians and the services guys really enjoyed working in it. And it's a very simple construction where you have these angle panels at the bottom of each, angle brackets rather, at the bottom of each panel, and you screw the whole building together in that way.
Can I interrupt you for 1 second?
Yeah.
Just to clarify something, because you went through regulations. I know this, but I just wanted to clear to everybody in Turkey anyway, that the municipalities, actually, the building regulations require you to do the carbon calculations these days. Am I right?
Well, it's not in policy yet. We're actually working with one of the London boroughs, and they are updating their policy to include that, and that's going to happen in early next year. And the GLA are asking, so it's not specified what the carbon content of your building needs to be at the moment. What they're asking is for everyone to submit their LCA for a project, so that they get a sense of what the carbon footprint of buildings currently are, so that then they can use that as a benchmark to then implement policy. So it's not in policy at the moment, but it will become.
But it will be, yeah.
Yeah.
No, that's a key difference between Turkish experience and European experience, that government and local government takes proactive action towards COP26 ideals. That's a very key important factor here. The other thing that I want to ask you about, because this will come to people's minds, what about earthquake design in earthquake zones? Such CLT projects presumably are also quite good for earthquake design because of the bracing that you get across all planes, don't you? Because this reminds me of tunnel form construction, which is used a lot in Turkey, which is a concrete system that also lines up all the elements all the way up. So this would also work quite well in terms of earthquake design, wouldn't it?
Yeah,
even
absolutely.
on a multi-story building.
Yeah,
right.
And also because it has an element of slight flexibility in it. And actually one of the projects, the research projects that we're doing called Building Wood, which I'll touch on a little bit, we've actually got the University of Athens doing seismic testing on the project,
right.
which is a glulam frame project. But yes, there has been testing previously, and it does work in seismic areas.
Okay, thanks.
Great. So this is the final building, and as you can see there on the right, there is lots of, it's not just the carbon reduction that you get from using timber, but there are lots of other benefits which are really important to talk to developers and clients about. So there's less waste. In an inner city environment like London, it's really quiet. We have fewer deliveries. Also it's very lightweight, so your foundations, generally speaking, are much less than they would be if it was a concrete frame. And we loved it so much that we wrote a book about it, which I'm sure we can make available to whoever wants one. And then this is another project that we learnt lessons from Murray Grove and moved on to this large, it was at the time and may still be one of the largest housing developments in CLT in the UK. So this is a CLT honeycomb structure again. But in this case, I'm not going to go in too much detail about this, but whereas in Murray Grove, all the wall sizes were the same, thicknesses, were the same all the way up through the building. In this case, we adopted a slightly different strategy where the thickness of the walls around the perimeter provided the stability, and the internal walls were thinner. And then as we went up the building, because the loads become less as you go up the building, the thickness of the panels got less. So we started to investigate material efficiency in that way on this project. And you can see here in the UK, in London, brick is king kind of thing. And for planning reasons, we were asked to incorporate a brick facade. I think the key point here really is that buildings can look, they don't have to look timber to have a huge timber content. And I think that's quite an important message. It is about using the right materials for the right locations, and we can design in details that work for any cladding. But what we prefer to do in terms of sustainability is to use a much lighter weight facade cladding, so that again that minimizes the load, and then therefore we get more material efficiency. And so we substituted out 10,000 tons of concrete and replaced it with 1,930 tons of timber. And also in this particular project, we were able to add additional homes onto the project because the foundations were running above the HS2 underground railway line. So that meant that if we built it in concrete, we would have had to have had pile foundations. This was actually built on a raft, and the concrete in the foundations was much less. We had fewer deliveries, as previously mentioned. And then I think sometimes people worry about the carrying capacity of the forests in Europe. But as you can see here, if we look at this area of Austrian forest, it would take 3 hours to grow the quantity of timber that we've got in this building. And then we have also, in a kind of in a collaborative way, pulled together a book called The 100 Projects of UK CLT, bringing together architects across different disciplines and showcasing timber architecture to, again, try and break down some of those barriers that people perceive about building in wood. This is, so then just thinking a bit on a higher scale or a larger scale, this is a project I just threw in a couple of Scandinavian projects because of the link with Sweden, and this is in Bergen. And in this particular project, because Bergen's surrounded by 7 mountains, a lot of people are moving out of the city. So we were asked to look at perhaps building a master plan over a lake. And one of the things that we try and do with our projects is to make sure that from the very early stages of looking at the massing and how we can maximize daylight into a project, and through the massing reduce the energy load on the building internally. So in this particular one, we introduced solar corridors, which allowed more daylight in the morning and the evening to enter into the scheme. And this is a visual of what it would look like. And so these corridors, these canals, sort of Venice of the North, run through the project and through the amenity space to allow as much daylight in as possible. And it also grades up in terms of height. So it goes from low scale to the south and taller to the north. And all this would be built in CLT, and the foundations were made from tunneling that was happening. They're building a new railway around the city and going through the mountains, and they needed a place to put all the rubble. So we suggested this would be a good opportunity to make the foundations. So you get a sense of what this space could look like, and a boardwalk along the tall side of the project. Another Scandinavian project is Aastafältet, which we're doing for Folkhem. I believe you had a bit of a talk from Vinbeck, is it, about Strandparken, and it was the same developer that has commissioned us to look at this.
Yes.
This is a 229 apartment development in Stockholm. There are several plots in the Aastafältet master plan. And on this project, again, a CLT platform construction. In this case, we've got a tile cladding on the outside. So kind of moving towards that lightweight cladding that I mentioned earlier in terms of material efficiency and reducing loads, and therefore reducing the thickness of the timber that we're using. And this was really interesting because Jan Gehl were working on the master plan, and they had set out some principles about how the blocks were going to be broken down. But again, here, just as an overall concept, thinking about how daylight and sunlight gets into the project and maximizing these solar corridors to make sure that the courtyard in the center of each of the blocks will be lit as much as possible, and the flats surrounding it will be daylit as much as possible, thereby reducing the energy load on the building. And this just gives a flavour of some of the facades that we looked at, which also incorporate some of Jan Gehl's principles about places for seating, breaking down the facade into, I think it was 60 metre, 30 metre, 18 metre, and then 6 metre zones, so that you get a real human scale to the project, which was a really lovely opportunity to work with those parameters. And there, that gives you this is the Jan Gehl kind of master plan requirements. Then moving on to modern methods of construction and manufacturing, and how we can bring more efficiency into architecture and building. So we can see here, you know, the automotive industry has evolved unrecognizably from its beginnings at the beginning of the 1900s, and these are made, you know, they're made of a kit of parts that are brought to the factory and assembled. So it's an assembly line. And this is an example of the LNG assembly line, we help them to develop their modular product. And this is also made out of CLT. So it's a CLT modular design. And L&G, being a big investment company, saw the benefit of going towards a more mechanized way of building. Again, just touching on how, it's about parts coming together. And if you're thinking about, the number of parts we have to bring together, if we go for a light gauge steel option, there are so many more components than the simplicity of a CLT module. And I think a lot of people are concerned about the potential repetition that you get with modular. I think there are some projects that are much better for modular, in my view, than others. For example, student housing and hotels, where you have a very repetitive model along the way. But these were actually designed for homes, which were individual homes as well as for multi-story. And we needed to build in quite a lot of flexibility into the system itself. And in order to help, this one was for Swan Housing, who have also built their own factory. And we helped them to develop a design guide for their product, as well as helping them with the manufacturing process. So it was a really fascinating project to be involved in, and also meant that we had to rethink how architects think about building, because in a conventional build, it's not really our responsibility to worry about how parts of the building arrive on site. But when you're thinking about modular, you've got to get it from the factory to the site. So how it's going to be transported, how it's going to be lifted into place, all need to be considered. So it's a whole new way of thinking. And this is some of the modules being put in place, and Watts Grove, which is on site at the moment, which is 65 homes in Tower Hamlets, and is put together with a mobile crane. I think what's fascinating about this is that it starts to help us think about how we can digitalize construction, and this idea of digital twinning, which is something that we're looking at with our research projects. In this example, Vitsu headquarters, which is also in the Midlands. I don't know if you know the Vitsu shelving system by Dieter Rams, which was developed in the 1960s. It's a kit of parts, so it fitted very well into what we are trying to do with the way that we're developing our designs. And so we used that concept, and initially this building was only going to be 10 bays long, but as the brief extended or developed over time, it ended up being a much bigger product, and you could even add more bays on even after the building is finished. So this is it has a modular roof light system. It says CLT roof panels, Baubucher primary frame, which is an LVL frame using beech. Which is really beautiful, which also means that it's incredibly high precision and smaller members than you get with glulam.
Can I ask a question?
Ooh, yeah.
Can I ask a question about comparison of cost to an equivalent concrete or steel frame building?
Yeah.
Have you done that kind of study as well? Did you do a cost analysis of the?
Yeah. No, we're often asked to do that as part of our, viability assessments for projects that we're working on. And in an inner city site like the first two projects that I showed you, where you've got reduced, conventionally here we have in situ concrete rather than prefabricated concrete as part of the typical concrete frame building. And the time that takes to dry and cure and everything can be offset by the speed and the time reductions that you get with building out of timber. So actually, it's very equal, and that's how we've managed. Particularly for clients who aren't coming to us for a timber building, there are many benefits along the way that they realise it's a good alternative for that reason. I think.
So you don't have to sell it purely on its environmental credentials.
No.
It's also cost equivalent, especially in a market like England.
Yeah. I think there would be sort of maybe the big distribution warehouses made out of steel. I think we might struggle a little bit more to get those over the line in terms of the costs. But interestingly, Stora Enso have just developed a industrial glulam system, which includes CLT, and is a really interesting. They've got various different scales and sizes, so they're working towards a more industrial approach and how we can substitute out steel and concrete for those sorts of buildings as well, which is fascinating.
So the argument against cost is diminished as well. There's no longer
because the more they build, the cheap, the lower the costs. And once you've got a system that's sort of set in stone, you know what the parameters are, you can roll them out more easily.
Yeah.
So this is it under construction, and this is it completed. And I think what was so great with this project, as I hope you can see from the image here, is the precision engineering of it, and also the simplicity but beauty of such a gorgeous timber interior for this particular purpose. And this is a project we've got on site at the moment called Black and White. It's just around the corner. So if anyone's over in London, we're always happy to take you on a site visit. And this is our Black and White project, which is a commercial building, offices. It is 4,500 square meters and is made again from an LVL frame with CLT floor plates. The timber facade is parametrically designed to respond. So each facade is slightly different in response to the sunlight and to minimize overheating in the building. And this is a CGI of it, which was a planning CGI. And what we're finding, because we've done a few commercial buildings now, this is our third office building near the office. We have others around the world. But what we're finding is that developers are coming to us now for that biophilic and sustainable model that they can sell to possible tenants. And I think this is something that we're going to see more and more of. Well-being for employees is becoming really important. So yes, it's made from bio-based materials. It sequesters 55 kilograms of CO2 equivalent per meter squared. It's passively designed as much as possible to enhance natural ventilation. And the carbon footprint has been reduced by as much as 60% if it had been made out of concrete. And this is it on site. So you can see here again, this precision engineering that you get from this, the off-site manufacture, where the beams and the posts are all built from and set out by the architect's model, or a translated version of it. And what we need to get closer to is how we can link all the consultants' information seamlessly through to manufacture, so that the holy grail really is kind of the same as building a car. It's a production line. When you get to site, it's bringing together components rather than actually every single part of the building coming together. And you can get a sense here of how these spaces are going to feel when they're occupied. And then finally, I'm just going to touch really quickly on the Build in Wood project that we're doing, which is an EU-funded project, 10 million euro, where it's led by the Danish Technical Institute. And the whole purpose of the project is to break down the barriers, the perceived barriers of building in timber across Europe. So the objective of it is to design a multi-story system that can be used for residential and commercial up to between 4 and 10 stories, because at the time when we were looking at this, we thought, well, what are the typical heights that you would get across Europe? In London, we have a tendency to build very tall, but across the rest of Europe, or certainly not in the major cities, there's, it's a lower scale product that's needed. So that's why we ended up with that as a dimension. And then we had to look at different regulatory requirements in terms of building regulations, look at the different markets, and also, as I touched on right at the beginning, thinking about retrofit. So the facade panel should work not only for the system, for the structural system, but also for applying to other existing buildings, which may well be concrete frame. And we also, as part of that process, needed to maximize the use of natural materials, obviously, particularly timber, and think about reuse, disassembly and recycling, which is an important part of a life cycle analysis, to think about how to make sure that the building that you're designing, albeit in 80 years' time, can be taken apart and reused, and how can that process be optimized in the design of the building at the beginning. So there are various criteria that we've looked at and incorporated, and we were in charge of designing the system, but there are other work packages which include looking at using recycled timber in CLT. We're talking to early adopter cities about how their policy may change if they decided to think about promoting timber in their cities, and that's why we know about the Haringey situation, where they're thinking about embodied carbon, and that we're actually hopefully going to be building a few pilot projects out of the system as demonstrators, so that people can see in real life at one-to-one scale how this can be rolled out across Europe. So it needed to be accredited. We've got lots of testing going on with Knauf and the University of Athens, and also the Danish Technical Institute, about moisture and fire and acoustics. And then when we were looking at the different parameters for the project, we needed to identify a sort of range of performance, which is what this little symbol at the bottom is. So we have a range of different build-ups that can allow for different requirements in building regulations across Europe. And what we came up with was a kit of parts, which is very simple: post and beam, glue lam with either a CLT or rib deck floor plate, and then a non-structural facade panel, which can be adapted to different thermal performance and acoustic performance. And this is the system that we've ended up with here. We did look at we went through a process of looking at all these other ones, which I've already shown you examples of, but I think what the use of structural timber and engineered timber is evolving all the time. And I think this issue and the importance of material efficiency is a really important one. So when we're looking at a timber frame like this, a glue lam frame, we're using much less timber than we would in a CLT honeycomb structure.
What's fascinating is that it's looking more and more like a concrete frame,
exactly.
but in timber. I mean,
well, and actually, in a way, that's really good, because it's really easy for builders and clients to get their head around.
Well, also much of the work is done off-site, and that's the most attractive side of it. Is the site is less messy. You spend less time on site. But the thing that will stick in everybody's minds is fire. I mean, how do you deal with fire regulations, especially in multi-story buildings? What's the fire equation there?
Yeah, so we've done an assessment, or the Danish Technical Institute did an assessment of fire regulations across Europe, and this is open source. So if you go on the Building Wood website, you can access all this information. And as we develop more of the system, the more will be available as well. And you can see here there are different regulations across Europe. And these arrows mean that, once you get to this height, you can, so that would be 90 minutes right up to a total height of 50 meters. So there are different regulations across Europe. And actually the UK is the most regressive of all the countries in Europe, because we had the tragedy of the Grenfell fire. But what we're doing in the project with NAUF and the University of Athens is actually doing more testing of timber, and we're looking at the whole build-up with plasterboard, etc. And there is a lot of test information out there which demonstrates the viability and the performance of CLT in fire. And this just shows you the kind of range of different, once you've got your building, once you know what your site is, whether you're building a residential or a commercial project, you can then put in the parameters and identify what the scale and size of the frame might be, and whether you're going to use a rib deck or just a CLT slab. And it can work for commercial, residential, and extensions. We've already done a sort of pilot sketch scheme for a project in Trondheim where they want to extend some housing developments, and it makes a lot of sense because it's very lightweight on top of an existing 4-story building, to extend that with a couple of stories and then use the non-structural facade panel to overclad the whole building. So the opportunities and the options are endless, really. And just as a way of demonstrating that this isn't just research, we've got a project in Milan at the R-Expo, the Mind Milan Innovation Park for Lend-Lease, and they're using a really similar system to the one that we're doing for building wood, which is, so this is a glulam post and beam with a rib deck floor plate. And you get a sense of what that space might look like. They're due to start on site next year. And then finally, just touching again on the fire issue, in the UK, they've changed the fire regulations, so you can't have any combustibles in the external facade. So that has slowed, it has to be said, and this is only in residential. So the commercial side of it, I think we're seeing a real drive towards, as I mentioned before, buildings that give you a sense of well-being. With the residential market, we're looking at this as an alternative solution where we use, as we've said at the beginning, use the timber, substitute out the concrete frame for a timber frame, but overclad it with a non-combustible facade. And we're working with the fire engineer who has assessed the Grenfell Tower, Jose Carrera from UCL, and looking at how we can demonstrate that the fire performance of this building meets all current standards. And we're also working with housing warranty providers as well as insurance companies to get a warranted system that people have confidence in and doesn't stem the flow of sustainable construction. So we're developing details, etc. And this is sort of one of the visuals that we've got. Again, it's similar, it's a kit of parts, and then we've got this non-combustible facade, which would be a kind of steel frame system on the outside. Again, thinking about how we can make this all as lightweight as possible to minimize our material use. And that's the end of my talk. And this little picture is the number of pine tree seeds that it took to grow the trees that made Murray Grove. So I think it gives you a sense of that renewable story that building in wood really does give us. Thank you.
Thank you very much.
Thank you very much.
Very, very nice presentation. Well, it's stupendous, actually, the amount of timber construction you have got under your belts. It seems like as if it's been going on for quite a long time, but actually it's the development of the last, at the most, what, 5 years, is it?
10. I mean, I
10
suppose
years.
Murray
Was
Grove
it?
started in 2008, but that was quite a one-off, and then from there it's sort of grown.
But it's exponential. The growth
Yeah.
of interest is exponential, isn't it? And England is, in relative to other countries, is catching up relative to, let's say, Austria or maybe Denmark. And you're one of the causes for that catch up, by the looks of things.
I think, well, we've certainly, and Andrew has definitely been. I mean, what I was fascinated. I was at a meeting on a couple of weeks ago with some of. I felt very strange to be there because I was asked to go with someone from Cambridge University to talk to some of the biggest sort of investment owners in the UK, if not the world. And it was the most bizarre thing. And they were talking about, the whole conference was about systemic issues. And what was astounding to me was that, you know, we've been talking about timber for a very long time, and Andrew certainly has been beating the drum, sometimes with not much response. And I found myself in this room with people who make some of the biggest decisions about the world, the way the world's going to be. And they were really fascinated, interested. They were already on board with a lot of the principles of it. And I think I think we are really seeing, we're at a moment that because of our, you know, the climate crisis, I think we don't really have many options. So,
no.
you know, it was really interesting to be at that.
But do you think that COP26 will have a big effect on that? It seemed like a lot of hot air again.
Exactly.
But
yes, I know.
But I think only through practice and demonstration that people get over their psychological barriers. I mean, I think timber does have a lot of psychological barriers, especially in this country, in Turkey. It has just stopped dead in its tracks, as it did in many other countries. Sweden had the same experience. For hundreds of years, it was a timber-rich country, and then it stopped because of fire mainly. And then as the regulations relaxed, it started again.
Yeah.
But is fire the most problematic issue, do you think? The fear of fire, what can you say about that? I mean, is that something that's going to be got over pretty quickly?
I think so. I think there is enough testing and test results that have been provided that that demonstrate that. I mean, for residential, you don't in a multi-story building, and also it's also about the scale as well. I think, you know, if we're talking up to 18 meters, which was the new model building, the last project that I showed you, that in itself, there is no substantial, there is no risk with that when you've got non-combustible external walls. And I think, you know, like you say, Sweden is actually quite a pioneer in this now, and they're moving forward very quickly with their timber construction, and they're seeing the benefits, because, you know, even in Sweden there was a legal case against a limestone mine because of its environmental effects. So they're you know, it's this shift in agenda, and I think, yeah, you're right that there's probably a lot of COP that was hot air, but what we can see on the ground with the early adopter cities that we're working with, like Amsterdam, Trondheim, London, and others, we are seeing real policy change, and I think that's how ultimately it will get embedded.
Right. We hope that we can get you over to Turkey to do a demonstration as well one day.
Oh yeah, that'd be great.
We'll have to create that environment for it to happen. One question that came from a gentleman, Habib Jallo, how can we access the book that you mentioned? I was going to ask the same question. Can I have one?
Me too.
And Habib also wants one. Perhaps you can tell us how we can all get one of those books.
I might just have to. I will. I can't. I'm not sure whether we've got some in the office, and I think there was a point where you could get it on on Amazon, but I'm not. It might be out of print now, so I'll have to check and I'll get back to you with the detail
Okay.
on that.
Okay.
All right. Well, we'll pay for the DHL costs.
Okay, perfect.
You just tell us how many we can have.
Yeah. Okay.
And also we can distribute it from the circle if it's necessary. And obviously, I'm sure people will pay the cost of it. But it looks like it's a book that one must have. I mean, I think that there aren't any more questions. Maybe people should move on to the networking area, the sessions area, where there could be face-to-face interaction. What do you think, Ece?
Like me, because I have many questions. You don't mind?
Well, maybe you should ask them here. I'm going to have to run off in 5 minutes, so I will quietly disappear.
Sure.
But
maybe
I think
continue. Yeah, sure, of course. In 5 minutes, yes, you needed to go. But I'd maybe just continuing the previous question you asked about fire. Tomorrow we have a discussion panel named Psychological Barriers, Safety and Regulations. And when we were creating this content, we were like, of course, we need to talk about fire and we need to talk about earthquake. And then the Swedish side was like, well, we need to talk about water. And that is a big issue here. And we were surprised on our end because our major problem is earthquake and fire. So do you have a similar problem in England?
Yeah, and there are things that we do need to make adjustments to the way that we design, particularly roofs, because it doesn't work to have a completely flat roof in a timber building. But that doesn't mean it can't be 1 in 40 or something like that. The point being
it's like this, not too much.
Yeah, just a slight pitch. So, and the reason being is that waterproof membranes don't last forever. So once they do get damaged or whatever, we need a way to let the water not stand on the timber. So that's a really important one that everybody needs to design into their project.
Well, I mean, the most important thing about the facade is breathing, isn't it? That the timber has to breathe all the time. Because you don't imagine water standing in the facade, but if you design it badly so that the detailing doesn't allow water to drain out, then it will go towards rotting. And the other thing is termite protection, which presumably is not a problem any longer because you impregnate the timbers. Does that degrade over time, by the way? Does that have a lifetime, the termite protection?
Well, I must say I'm not an expert on termites. I think there are various places around the world where that is more of an issue, and
like Africa.
Yeah, exactly.
For example.
Yeah. So we don't.
Which is where a lot of the wood comes from as well to the world. So it's a bit ironic that in their own country they have a huge problem with termites. Yeah.
Well, and I suppose the thing with all the projects that we work on, the timber comes from Europe, and we try and avoid too much impregnation against insects. In fact, they don't include that in the timber because then it limits is that fine balance or a balance. We don't have termite issue in the UK or generally in Europe. So we don't need to do that. So and we also want to be able to recycle the timber, and I think impregnating it has an impact on that.
Yeah, surely. I do have more questions, but maybe some people are waiting to meet you in the networking session. And I'm guessing Serge Costa needs to leave.
Lovely to meet
you. So thank you for the lovely presentation, Kirsten. We're all going to move to the hop-in session room, which we also have the link in the chat box. If you would like a more informal discussion, please come and join us in the hop-in session room, and see you guys tomorrow.
Thank you.
Thank
Bye.
you. Bye.